Okay, so today we're going to go over 7.4, which is called congruent triangles. And this is a pretty big deal in the world of mathematics, is proving things. And so we're going to start off by proving triangles are congruent. Now, back in 7th-ish grade, you should have learned certain things about triangles and what would make a unique triangle, meaning if I gave you these certain parts of a triangle, how many different kinds of triangles you would be able to make. Now, if you don't remember it, not a big deal, but if you do remember it, good, because that's going to help you understand what we're going to do today. So the first thing is we're going to do this jump start together, and it says examine the diagram. In triangle ABD, is triangle ABD congruent to triangle CBD? List all the things that you would want to know in order to know for sure that these two triangles are congruent. Okay. So I'm just going to lay out a couple things first. The order in which you see these letters matters. Okay. Whenever they're asking you for if these two triangles are congruent, or they say that these two triangles are congruent, order matters. What do you mean, Ms. Johnson? So what I mean is when I put certain orders together, the first guy matches or corresponds to the first guy, and the second guy corresponds to the second guy, and so on and so forth. Okay. And it also not only talks about the points, but the sides and the angles. Okay. So when they're basically asking, is ABD congruent to triangle CBD, they're really asking, are are they congruent? Okay. And so the first thing that I'm going to do is I am going to um, say the thing that we need to prove in two triangles are congruent is right now, if you don't know, you have to list all of them. You have to list all corresponding sides being congruent. Like, for example, because AB, these two and these two, so we're going to go AB is congruent to CB. We'd have to list all the things are congruent. Okay. And I can't mark them congruent like this because then it's almost like saying that they are congruent. So we'd have to list all things congruent, all three corresponding sides congruent to all three corresponding sides, and all three corresponding angles congruent to all three corresponding angles. That's a lot of information. Okay. If you remember from 7th grade, there are some shortcuts, and that's what we're really going to focus on today. It says explore and justify triangle congruence criteria using rigid transformations. Okay. What do I need to know about two triangles before I can say that they are congruent? And then how do I verify that a set of criteria that seems to imply triangles are congruent will always work? So we know two triangles are congruent if all pairs of corresponding sides are congruent and all pairs of corresponding angles are congruent. Now, this is important because look, the only way that you can prove that these things are congruent is by proving all corresponding sides and angles are congruent. So we may wonder if knowing less information about the triangles would still guarantee that they are congruent. And that's our goal for today. Our goal is, do we really need all that information in order to prove triangle congruence? For example, we may wonder if knowing that two angles and the included side of one triangle, two angles and the included side. So when they say two angles and the included side, so if here's my triangle, that's only part of my triangle. They're saying this angle, let's draw two of those triangles, sorry. So let's pretend you have two of these. This angle is congruent to this angle of another triangle. This angle is congruent to this triangle, this angle of another triangle, and their included side, which means the side in between those two angles. Included means in between. Okay. So, okay. So, if they're congruent, if that would satisfy it, right? So, and then we will refer to this as ASA, as an angle, then side, then angle. Okay, not AAS, because that's a completely different, you got to pay attention to order here. Okay, is enough to know that the two triangles are congruent. And if we think that if this is enough information, how can we justify that this is true? So here's a diagram illustrating ASA for triangles. Based on this diagram, which angles are congruent to which angles? Which sides are congruent to which sides? So just reminding you that this little symbol here with a little arc mark, and there's only one of them, means that it's congruent to all angles that are marked the same. Similarly, that would be true too. So I should have used a different color there. So let me try this. Okay, so based on the diagram, which angles are congruent and which sides are congruent? Okay, which angles are congruent? So here I'm going to say angle A is congruent to angle R. Congruent is this symbol. It looks like an equal to sign with a top, the hat on it, and it has like a curl. Sometimes I write it so fast that it looks like, 3 bars. I also know that angle B is congruent to angle S. And I know that AB, notice he has a hat on, is congruent to side RS with a hat on. So that's saying those two angles are congruent and those two sides are congruent. And some of you are saying, Ms. Johnson, can I write that angle C is congruent to angle T? Kind of, but it said according to the diagram. So we're not going to add any extra information to that. Now, if you know why angle C is congruent to angle T, good job. If not, don't worry, we'll talk about that later. To convince ourselves that these two triangles are congruent, what else would we need to know? To convince ourselves that these two triangles are in fact congruent, what else would we need to know? Okay, so that's the question that we're going to answer. Okay, so based on our definition from before, we would have to know all corresponding sides are congruent and corresponding angles are congruent. Okay, so I am actually going to mark these congruent here. 1, 2, 3. 1, 2, 3. We know, and this is extra information. This is, we figured out that angle C is congruent to angle T because both triangles add up to 180, right? And if this angle A is congruent to that angle R and that angle B is congruent to that angle S, it implies that those third angles are congruent because they take up the same amount of 180 for both triangles. And then that leftover would be left over for angle C, which is congruent to angle T. If you're not sure about this, start putting numbers in and seeing if it makes sense. Like I would go, okay, well, let's pretend this one's 40. Then this one would be 40, right? And let's say this is, I don't know, 100. Then this would be also 100, right? So how much would angle C be? Angle C, well, what's the leftover of 180? Well, that would be 40 as well, right? And that would be 40 as well because they have to add up to 180. So do you see how that works? And you're saying, Ms. Johnson, you just put a bunch of numbers in there. Yes, I know, but that was just to show you, to prove that those third angles would be in fact congruent. Okay, so back to this. To convince ourselves that these two triangles are congruent, what else would we need to know? Now, according to this statement up here, we'd have to prove that all congruent angles and all corresponding sides were congruent. So we have the 3 sets of angles. We just need to list out the other 2. So we would still need to prove that, let's see, CB is congruent to who? Who would you write there? CB is congruent to who? Very good. You probably said ST. I agree. And then CA would have to be proved congruent to RT. Okay. So normally right now I'd let you use tracing papers so that you guys could use rigid transformation to do this. So if you can and do, go ahead and do that. Let's see. I'm going to skip that. So what would be so I will show you my list of sequence of transformations. What would you do in order to get there? Okay. And then so I would start off by translating it over from I would translate point A to R. And then there's many answers, okay? So this is, I don't know why, but I always like to move and then like rotate and reflect. Um so let's see. Yeah, I would translate A to R. So now you can imagine them sitting point to point. And then let's see. And then I would rotate this so that BA and RS are sitting on top of each other. So then rotate. So BA is the word they use is coincide is on top of. I'm going to use on top of RS. So now you have these two triangles, and then I'm going to reflect it. Reflect across AB line. Okay. So, sorry, I should say reflect triangle ABC across the line AB. Okay. So then then you would be able to see that it's exactly the same. Okay. It says your sequence of transformations, looks exactly the same. We translated, rotated, and reflected. We can see that the word coincides when we want to say the 2 points or line segments occupy the same position on the plane. When making arguments using translation, we will use this word a lot. So it says now the question is how do we know that point C has to land on point T in the reflection, making all of these sides coincide? So answer this problem as best as you can to justify the ASA criteria, guarantee that these two triangles are congruent. It might be helpful for you to think about to know point C can't land anywhere else in the plane except for on top of T. So if you can imagine this, right? So once you see and you rotated it and you reflected it, right? It is in fact that C and T go like they are on top of each other. It says because of the corresponding congruent angles, we know that the reflection of across that line, RS or AB, whatever you want to say, has to lie somewhere on this ray, right? But at the same time has to coincide with ST. So the only point that lies is T. Okay, so when I reflect this across, I know that this side here, C will land somewhere on this line, but also somewhere on this line. So it has to be that point. Okay. And then it says, okay, let's continue on. Okay. So they want you to use tracing paper again to do this. And this criteria is different. So we just proved ASA. So triangle congruence, I'm going to start making a list. So far, ASA. The other one that you also know is all sides and all angles being congruent. Okay. So this one right here, what I want you to do is first list out what they gave you. So what's the given criteria? And you see, it's a side. So go ahead and write that criteria out. Yeah, so this one actually is going to be called SAS. Okay. They gave you a side, then they gave you an angle, and then they gave you a side. So do you think these triangles are congruent? And then if you use tracing paper, awesome. If not, then why do you think they're congruent? And then they just want you to list the transformations. Again, you're practicing the transformations because that's one of the things that we just learned. Okay, so my answer is yes, and I'm going to show you my transformations. I'm going to move K onto Q. So translate K onto Q. So these are point, right? And let's see, then those look parallel. I don't think I'm going to have to rotate it. Oh, yeah. Okay, so then I guess I would do the same thing. I would rotate triangle JKL so that so KL coincides with QR. Now, if you notice, Miss Johnson, why did you put a line here? Oh, I just put extra arrows there. You don't have to. But I just want KL to be on top of QR. So in fact, I want to erase those because I figured out that I want it to be just this segment. So that KL coincides with QR. I want them to occupy the same space, not just be on the same line. And then last but not least, I would rotate it. Triangle JKL. Not rotate, sorry, reflect. I would reflect JKL across QR. Right? And then again, why am I justifying the fact that those two are in fact the same? And it has to do with the fact that JK and QP are congruent, right? So again, the angles are congruent. We got RQP is congruent to angle K. Those two angles are congruent. So when I reflect it back, you'll notice that JK will also sit on top of QP, right? And J is the same distance because JK is the same length as QP. That means that J has to be on top, coincides with P, right? So imagine if you had like, I don't know. So when you reflected it back, you can see that those two sides are congruent. Okay, I would like you to do this one. So because we proved that, now I have SAS. So those are the two I have so far, ASA and SAS. So I want you to try this one. What would this one be called, given the information that they gave you? Do you think the triangles are congruent? And give me your transformations. Okay. So go ahead and pause and then come back to me. All right. So you maybe you named it AAA, right? And are the triangles congruent? And I don't know. What did you guys think? Yes or no? So to me, I think that the triangles are not congruent because the one OIU looks larger, right? So here I'm going to say no. And when you list your transformations, like, can you imagine that O sits on top of Q? And then because this angle is this angle, and then when you did it, it would look something like this. Oops. Right? Where this is, let's see, this is U and this is I, right? So just because you have three angles being congruent does not mean that those two triangles are congruent. So this goes on my list of not congruent. So far we have A, and my joke is, if you know what AAA is, it's a like roadside car helper. Like if you lock your keys in your car or need someone to change your tire, you can call AAA. So AAA is good at helping you fix your cars. It is not good at proving triangles congruent. It's not. All right, let's do this next one. So go ahead and try this one as well and see what you get. Okay. So this one was SSA. And now, Miss Johnson, how come you can't put the A between the S's? Because this angle here is not between the two sides they gave you congruent. Okay, it's actually this angle here that's considered the included angle, and that's a big deal. Okay, so on the quizzes that I'm going to give you, please know that I'm going to give you a picture that looks like this and say, are these two triangles congruent? Yes or no. By which congruence can you use? And if you write that these two triangles are congruent by SAS, it's wrong, because this is not a SAS. It's not side then angle then side. Okay. All right. So are these two triangles congruent? And so here I would have done like a rotation here, right? And the answer here is no. Okay. So yes, you can have, I'm going to try to draw this picture out. Yes, you can have this angle congruent to this angle and this side congruent to this side. But notice here, I could have made one of the sides be this, which is 1, or this, which is also 1. And those are two different triangles. This pink triangle out here versus this yellow triangle are two different triangles with the same matching criteria. So as you can see, these two, this belongs on the not congruent list. So again, here's my not congruent list, and I'm going to write the bad word here. The bad word here is this. And so these two are not good. These do not prove triangles being congruent. Okay. All right. Here's the next one. I'm going to have you do this next one. And which one is this? What criteria would you call this? Yeah, this would be considered SSS. Are these two triangles congruent? And the answer is yes. So let me go through this. So triangle congruence, these are the good ones. We have ASA, SAS, and we now have SSS. Okay. The ones that don't work, right, are AAA and the bad word, ASS, right? So these are your triangle congruents, and we would, I need you to remember these, okay? So number 10, based on these experiments and justifications, what criteria conditions seem to guarantee the two triangles will be congruent? This one you can now answer. It said your friend wants to add AAS to the list, even though you haven't experimented with this particular case. What do you think? I'm going to have you guys do this one. I'm going to have you do 11 and 12 on your own. Okay. And we'll come back together as a class, and then we'll be able to figure out, what about AAS, Miss Johnson, and HL? What do you think, Miss Johnson? Are those two going to work out? So I want you to finish off 11 and 12 on your own to see if those two would work. Thanks for listening.